So now we're going to talk about circular motion. And so what I want you to do is imagine that there is a circle. It could be a wheel or something like that. And there is a point on that circle that's traveling along the surface of that circle. Now there are two ways to measure how fast that point is moving. There's linear speed, which is what we are most familiar with. That is where we compare the distance traveled versus time. So this is going to be some distance divided by time. So units that we're familiar with as far as linear speed is probably miles per hour or feet per minute. Is going to be some distance divided by some amount of time. Now the angular speed is the rate in which the angle is changing per unit of time. So this is going to be in radians per unit of time. Now we have formulas for linear and angular speed. Those are here. Angular speed uses the symbol that looks like a W, and that's called omega. And so we're going to take the change in the angle, which is going to be in radians, over t and time, and that will give us our angular speed. For linear speed, we have two formulas, and S in this formula is the distance, and t is the time. And in this formula for linear speed, we can compare the linear speed and write it in terms of the angular speed by multiplying the length of the radius, that's our r, times the angular speed. Now there are two other things I want you to know for this. When we talk about rotations, one rotation, which also can be called one revolution, there are two ways that we can write this down. When we look at a revolution, we can look at it at the distance that it travels. So one revolution would cause a circle or a circular object to travel 2 pi r, and this is in distance, because that is the circumference of the circle. So if you imagine that wheel is a string and you cut that string in one place and you unroll it, one revolution, which would be one pass around that circle, would be the length of that string. That's how far you would travel, which is the circumference of the circle, which is 2 pi r. Now, if you talk about it in terms of angles, one revolution, that angle would travel 2 pi radians. If you're talking about in terms of how the angle changes. So the word could be used as one rotation or one revolution, and if you're talking about it in terms of distance, that would be 2 pi r. That's how far it would travel in one revolution. And if you're talking about how much the angle changes in one revolution, that would be 2 pi radians. And of course, if it's in degrees, you could say it would be 360 degrees. When we compare linear speed to angular speed, and we use this formula here, where we can write linear speed in terms of angular speed by multiplying by r, the units have to be the same in angular speed versus velocity. The units have to be the same in the angular speed versus the linear speed. So if the angular speed is in minutes, then your velocity needs to be in minutes as well. And if your velocity is in, say, feet per minute, then your radius needs to be measured in feet. So your units have to be consistent in order for this formula to work. So now looking at the first example, a truck that has wheels 48 inches in diameter is traveling at 51 miles per hour. Now this is your linear speed, which is your v, because it's given in the change of distance per time. So when you're comparing distance and time, that is linear speed. So that's your value for v. We can get our value from r from the diameter. The diameter is twice the radius. So this tells me that the radius is 24 inches. Part A says find the angular speed of the wheels in radians per minute. So we need to find the angular speed in radians per minute, which means we want all of our units in minutes. Time units must be in minutes. And also our distance units must be in inches, because we have the radius in inches here, but here we have it in miles. So we have to make sure that we change the miles per hour into inches per minute. We need to make sure that our units are consistent. That is going to be the hardest part of this problem, because once we have the units adjusted, we just have to plug into the formula. So I need to change 51 miles per hour, and I want to change that into inches per minute. Well, I know 1 mile is 5,280 feet, and I know 1 foot is 12 inches. So I can cross off my feet, cross off my miles, and now my units currently are in inches per hour. But now I have to change my hours into minutes. Since I want my hours to cancel, I'm going to put 1 hour on top is equal to 60 minutes. So this will give me my value of V in inches per minute, because now I can cross off my hour. So in my calculator, I'm going to take 51 times 5,280 times 12, and I'm going to divide by 60 since 60 is in the denominator. I'm going to get that my linear velocity is 53,856 inches per minute. That is the hardest part of the problem, is making sure that the units are correct. Okay, now that we have inches per minute as our units, I can now use my linear speed formula that V is equal to R times omega. And I can solve this for omega. To find omega, I would just divide both sides by R. So I know I got to take my linear speed and divide it by my radius. Now my linear speed in inches per minute is 53856 inches per minute. And then I'm going to divide by the radius, which is 24 inches. So now I can get rid of my inches, and I'm going to take the 53,856 and divide by 24. And I'm going to get that my angular speed is 2,244 radians per minute. So here's my final answer. Now, part B says, how many revolutions per minute do the wheels make? So what we have right now is 2244 radians per minute. And we want to change that to revolutions per minute. Well, I know if I want to compare revolutions to the number of angles that sweep through, I know one revolution is 2 pi radians. So I'm going to use this conversion factor. And I'm going to put radians on the bottom. 2 pi radians is equal to 1 revolution. So now I can cross off my radians, and I can get what my speed is in revolutions per minute. So I'm going to take 2244 and divide by 2 pi. That's going to give me 357.1436923 revolutions per minute. And let's round it to the nearest revolution. So let's say approximately the wheel will turn 357 times in 1 minute. For the next example, it says a car's wheels are 28 inches in diameter. So that tells me that the radius is 14 inches because the diameter is twice the radius. The question is asking how far in miles will the car travel if the wheels revolve 10,000 times without slipping? So we need to figure out what 10,000 revolutions would be in terms of distance, and they specifically want the units to be miles. Notice that our radius is in inches, so we're going to have to do conversions here. We know 1 revolution is 2 pi r, and since we want this in miles, we got to make sure that we put this in miles. Because 1 revolution, if you imagine that you spin a circle 1 time and you want to see the distance that it traveled, that would be the circumference. So it would be 2 pi r. So as of right now, we have 1 revolution would be 2 pi times 14, and this is in inches. So I want to figure out what that would be for 10,000 revolutions. So I'm going to multiply both sides by 10,000. And that will give me the distance in inches. But then we would have to change it to miles to completely answer the question. So I would take 10,000 times 2 times pi, and then times 14. So that would give me 879,645.943 inches. But now we got to change that into miles. So I know that there are 12 inches in a foot. So I'm going to take this number and divide by 12 to figure out how many feet. So that would be 73303.82858 feet. And I know that there are 5,280 feet in a mile. So now I'm going to divide again by 5,280. And that's going to give me 13.88330087 miles. And then if I want to round it to 1 place or 2 places, let's say 1 place, that would be about 13.9 miles would be the approximation.